thank you everyone for joining us today. This is the second session of the course on 3D recording. I will share my screen now. Is that okay? Yeah. So yesterday we were having the class number 1, which was dedicated to the relief of paintings. And we were talking about the concepts and the importance of focusing on the texture of works of art. We were looking at what was the evolution in the last 20 years, more or less, that we followed in the Factum Foundation and also other teams that were working in parallel to us in order to get to the systems that we are currently using for recording the surface of things. So I showed you the development of this system that was developed by Factum, which is the Lucida 3D scanner. This is what we are going to be talking about today. So today is going to be the first workshop, and we want it to be more practical oriented. We want to actually show you like an introduction of how the Lucida system works, how it operates both in hardware and software in a very basic way, just so you can have a general notion of how it works and how we use it and all the different possibilities that it has. We are talking about the Lucida scanner because in our experience, currently, this is the system that is more useful for capturing many different types of materials, many different types of objects, and giving very high quality results. So this is one of the systems that we are going to be talking about in this course, because in the next sessions, we will also be talking about how we approach photogrammetry and also how we are working with new systems of stereo photometric recording. But today, we're going to focus on showing you what are the possibilities of the Lucida scanner. And for that, we have Guendalina Damone, who is my colleague in the Factum Foundation. She's based in Italy. She's dividing her time between Venice and Milan. And she's an art historian and curator. And she's also one of the persons in Factum who is constantly operating the Lucida scanner for different projects throughout Italy and everywhere. She's part of the people in charge of coordinating and bringing new projects to the Factum Foundation and actually carrying out the practical work of working with the Lucida scanner and with the data that we obtained with it. So I asked her to join us today because she's an expert in many aspects of how the Lucida works. So it will be important to have her point of view and her explanations. So I would like to divide today's session in 2 parts. The first part is going to be about showing you some material that we have prepared in the form of 2 videos and a series of slides about how it works, the Lucida, when it's about recording the surface of an object. So it has been developed, this information, as if it was a user's manual, as if it was like a kind of a user's guide for someone who had to actually be using the system. But it's only so you get this feeling of what is the scale of the object, of the equipment, how it works in relation to the object, what is the type of data that we are actually obtaining, and what are the typical difficulties that we can find when we are actually using it. The second part of the session is going to be about what are the different practical applications that the scanner has for research and study of different works of art. Yesterday I was talking only about paintings, but today I'm going to be talking about other types of materials, no paintings. We're going to be discussing maps and manuscripts, texts, even sculptures, And we are going to be talking about how we extract new information out of these recordings that could help art historians and restorers to know more about the history of the objects. So it's going to be about showing you what are very practical and very specific applications of the system, so that you can get an idea of what are the uses beyond making facsimiles or beyond getting an archive of the texture of something. So we are going to begin with these two short videos that I think will give you a very well introduction to the system. I will play the first one. And I will welcome Guendalina if she wants to comment something along the way.
Thank you for the introduction. Buongiorno a tutti. Not showing the video camera.
Yeah, Carlos, maybe you're sharing your presentation, but not the screen. Well,
sorry.
I didn't.
Say again, sorry?
You
cannot see the video?
No,
Okay.
because you're sharing the presentation, but not the page
Okay.
where the video is.
Give me
In
a
the
moment, sorry.
meantime, previously, while I was introducing, I forgot to mention that today the presentation would be part in English and part in Italian. And for all our users, for people listening, if you have, as usual, any question or every need of translation, both in Italian or in English, you can ask. And again, the chat is where you can type your questions or well, ask to speak.
Thank you. Is that okay now?
Yes.
Yes.
So I would like to say that, as you know, the system of Lucida is something we create basically for our projects. We are happy to facilitate other institutions to acquire a scanner. For example, the National Gallery in London bought one of these scanners a few years ago, and they're using it for recording their collections. So along with making the system, we created a series of materials like publications, users' manuals, and different operators' guides, along with videos like this one, so that people could actually learn in a very practical way how to use the scanner. The software of the system is also developed by us, mainly by Manuel Franquelo, the person behind the system. So all the software and all the algorithms that are necessary to actually run the application for scanning and also for processing the information that we capture are also made in-house. So this is why we are showing in this video very quickly an introduction of how it works and more or less what are the basic elements that it has. Before starting any scanning session, it is necessary to do the calibration of the cameras. This is something that is done every time we are assembling the scanner from scratch. So the calibration consists on telling the software that each of the two cameras that are going to be looking at the laser, each camera is looking with some perspective, and that perspective has to be corrected. This is why we are using this tool, in order to have a shape that we know how it is and how much it measures, so that the calibration consists basically on telling to the system that what the image that each of the two cameras is capturing, it has to be corrected in terms of the perspective, and also that each of the cameras are actually looking at the same shape. So when the scanner is interpreting the information from the video, the system knows that the information from each camera needs to be processed in a certain way in order to give coherent information. At the end, this system is about converting black and white video information into something that has relief information. So the video footage that we are capturing with the cameras, which is basically the line of light dancing or moving as the scanner is moving across the surface, that is something that needs to be converted into 3D information, into topographical data. So before I move on to the next video, this is just to show you this project that I was discussing yesterday about one of the main initiatives that we have been doing with the Museo del Prado in Madrid. And once you have seen what is the assembling of the scanner, this previous video I was showing you, this is like what it looks like when it's a real job, how it is the actual recording of a series of paintings in a museum. So as you can see, the important part in the system is the scanning head. That's the main part that we are looking now on the screen. And that head can be adapted to different kinds of structural frame. It can get higher or wider depending on the artwork we are recording. So as you will see in this very short video, we have been adapting that structure to the paintings that we had to record. On the screen of the laptop, we can see on real time the information that we are capturing. That is my colleague Guendalina recording in the Museo del Prado. And this is very important because the fact of being able of understanding the data that we are capturing more or less at the same moment as we are recording, it can help us detect any possible mistakes or errors in the data so that we can correct or rescan as we move along. Each of the paintings, each of the 14 black paintings by Goya, they were recorded by us with the Lucida 3D scanner and also with panoramic color photography, which is a completely different system. So for capturing the color, it's more about placing a camera at a certain distance from the painting, let's say at 4 meters or 6 meters distance. And from that point of view, it is possible to capture like a mosaic of rows and columns of small pictures in very high resolution. And then we can combine them together into one single file of the full painting in high resolution. This is what we're doing here. For a project like this, it was necessary, as you can imagine, a perfect coordination with the team in the museum, because there was a very rigid calendar, a very specific schedule that we had to move, that we have to work along. And the idea was that only one painting at every moment had to be out from the gallery space, so that the visitors were only limited to only not seeing one of the paintings. It's just about keeping the normal activities of the museum as much as possible in a normal way. So everything had to be perfectly calculated in terms of time, in terms of the logistical elements that are necessary to overcome any possible problem. And this is something that requires a lot of planning and a lot of anticipation. I will try to go back to the presentation now. So this was, I think it's better to show a video like this so you could understand more or less how the system moves and how it behaves in front of the object. Because sometimes with pictures, you don't really get the idea of what is it in practical terms. And now we would like to show you more or less the different steps that involve the process of recording and then working with the digital information that we captured when we are doing a recording job. The first step, or let's say the 0 step, is the scanning. This is what I was just showing you in these videos. And I will show you what happens when you are finishing a scanning. What are the types of file formats that you are obtaining? And then what are the 4 or 5 steps that are necessary in order to prepare the information for prototyping in a physical way or for any other way of output. Could it be digital or material? I will give the word to my colleague Guendalina in a moment. I would like just to introduce that in order to show you this step-by-step process of how to operate with the information of Lucida, we decided to do it taking as an example the information that we recorded in the Cenacolo Vinciano a few years ago, also in 2014, 2015, as a demonstration of the possibility of the system while we were working on recording the space and the painting of The Last Supper by Leonardo. So what we were doing is we were capturing the space with a different type of 3D scanner, with a LiDAR scanner. We were also focused on capturing the color of The Last Supper with panoramic photography. But what is important today is that we were trying to show what are the applications of the Lucida scanner, not on the painting by Leonardo, but on the wall in front of it, which represents a crucifixion by the artist Montorfano. This is what you can see in these images, how we placed the scanner in front of this wall to record the fresco. And we were doing it only to capture 1 square meter. So it was just focused on a small test in order to show what was being possible. When we are scanning with the Lucida, after we have done 1 session, what we obtain is a folder with a series of files. And I will just to very quickly review what are these files, because this way you can understand the type of information we are generating. Basically, we are recording video, and we are capturing video and archiving in a raw state. That means without any processing or without any compression. So the video that we are recording in the AVI format, it's actually the result of all the different frames that are being captured as the scanner moves across the surface. The way we do it is that the scanner records a linear guide of 48 centimeters. So in that process, we are capturing a total of 4,800 frames for each camera. And that means this is why the resolution of the scanner is 100 microns, because there's 1 frame every 1/10 of a millimeter. That's the reason why we are saying that this is the resolution of the scanner. So effectively, we are capturing a series of video frames that they look more or less like this. It's just a black and white video of the specific shape of the laser line in that precise moment on top of the surface. This is just a very simple diagram of how it works. So 1 stripe of recording is composed by these 4,800 frames of video, and that is composing 1 stripe of 48 centimeters. And then what we call the basic tile or the scanning tile, this is the essential module of the scanner. So when we are recording a painting, what we do is to record modules or sections of 48 by 48 centimeters, and then we can move on to the next one so that we compose a mosaic of the full surface of the area. So this tile is composed by a total of 20 stripes. So the scanner is actually moving horizontally, then it's going down, then the scanning head is going back horizontally and then down again. And this way, in this zigzag movement, we are completing a scanning tile. Then this video information is automatically converted into another types of 3D files that we will be using in different steps of the process. The basic type of 3D data is something that is called RIS. It's a way of showing 3D information as a series of X, Y, Z coordinates. That means that in this scanning tile, we are locating each point by its coordinates in a plane with its correspondent Z in the heights or in the depth, if you want. We are, of course, composing a scanning tile of 4,800 by 4,800 points of information. Other types of files that are generated automatically are what we call the grayscale depth maps. This is actually a way of showing 3D data that is very effective because it's not creating very large files, but it's actually giving all the 3D information that we need. You have to imagine an image file, like a TIFF normal file, composed by pixels, each of them having a different tone of gray, so that we are assigning a specific height for each specific tone of gray. There is a direct relation between the tonal information and the relief information. Here it looks just like a flat gray square, because in fact each of the pixels have very subtle variations in tone. We don't really get to see it on the screen on a visual level, but this is information that we can then export to other types of software, and it could be interpreted as actual relief information. And this is interesting because we are working with 3D data, but we are using TIFF files. That is, we are using images. The reason why all the levels of gray are very similar is because the scanner has been assigned a total maximum depth of half a meter or 500 millimeters. And all the possible levels of gray in a 32-bit file between the black and the white, all the different steps in gray is giving a specific information of height. But for most of the objects that we record, this range of heights is not between 0 and 500 millimeters. It's usually something much more shallow, much lower relief, which is moving in a range of a few centimeters, between 2.5 centimeters being the maximum range of one scanning session. So this is why in this diagram, I'm trying to explain that the topography of any object, of most of the objects that we record, are actually contained in between a very small range of gray tones. So this is what happens when you are working with 32-bit files, but we are also generating 16-bit files, which contains less steps or less levels of gray in between the black and the white. And this is just a way to show you that our data that we are capturing with this scanner is usually contained in a very limited tones of gray. But for what we want to do is more than enough. We don't really need to be using the full range between the black and the white. We just need to be aware that we are converting each different tone of gray into a specific height. And finally, the last type of file that we are generating when we are doing a scanning session is the shaded render. A shaded render is also an image file. It's a TIFF file, and it is like a simulation of the relief. Many of the images that I was showing yesterday and that I will show today are actually this type of image. It's like a virtual representation of a raking light, as if we were projecting a light from one specific direction, so that we could understand the relief of that object. So this type of file is not really 3D data. This is an image representation of the 3D model that we are obtaining. But it is very important for us to also have this information, because this way we can see what we have recorded and we can really understand the texture that we have for the following steps of processing that we are going to be doing. Maybe if you want Guendalina to explain these following steps.
Yes. Thank you, Carlos. I'm going to talk in Italian, but as Costanza said at the beginning, we can easily translate or answer. If you you can simply ask inside the chat, as you are doing at the moment for the audio. I hope that everybody can hear as well now. Quindi buonasera a tutti. Allora, come diceva Carlos, sostanzialmente al termine della scansione, quindi del processo di registrazione che vi è stato spiegato all'interno dei video che avete visto, che ha reso, diciamo, questo processo, diciamo, più semplice, considerando che farlo virtualmente è davvero difficile e, come diceva anche Carlos, attraverso immagini è complicato spesso rendersi conto di quello che è un processo di scansione, di assemblaggio della macchina, di posizionamento, connessione dei cavi con i video. Sicuramente per voi è stato più semplice, diciamo, rendervene conto. Quindi al termine di una scansione, sostanzialmente quello che avviene è un processo di elaborazione delle informazioni che ha inizio appunto con la fase di merging. Quindi merging, come recita la slide che state osservando adesso, vuol dire sostanzialmente il combinare due o più scansioni in un'unica tile, quindi in un unico riquadro. Come vi è stato spiegato prima appunto dal mio collega, la macchina lavora per moduli di 48 x 48 centimetri, il che vuol dire che al termine di una scansione io devo sostanzialmente muovere la macchina e scansionare, diciamo, una tile successiva. Però è possibile appunto che durante il processo di scansione qualcosa non venga registrato correttamente, come potete vedere all'interno di questa immagine dove vedete una parte nera. Quindi che cosa accade in questo caso? Stiamo registrando, stiamo effettuando la scansione, ci rendiamo conto che per alcune ragioni lo scanner non riesce a visualizzare, a registrare queste informazioni, e quindi quello che effettuiamo è una nuova scansione soltanto dell'elemento che non è stato registrato dallo scanner. Quindi esatto, in questo caso successivamente con l'applicazione di merging noi possiamo cucire, combinare all'immagine principale il riquadro che è stato riscansionato ed eventualmente non è necessario, insomma è possibile che durante la scansione non ci sia soltanto un elemento che non è stato registrato, ma più di uno, appunto come vedete da questi tre riquadri. Quindi attraverso questa applicazione, prima di iniziare il processo di elaborazione appunto delle immagini, di pulitura e di editing, quindi effettuiamo il merging. Quindi combinare due o più scansioni in un'unica tile, e lo facciamo appunto per svariate ragioni, ovvero elenchiamo in questa slide quelle che sono le, diciamo, principali motivazioni per cui lo scanner può non riuscire a scansionare un elemento. Quindi la prima può essere che lo scanner vada out of range. Quindi che cosa vuol dire? Che il nostro asse Z, diciamo, non può essere lo stesso per l'intera superficie scansionata, e quindi quello che facciamo è cambiare la distanza del nostro scanner dall'opera. Come avete visto prima, nelle prime immagini, insomma nei primi frame del video, si vedeva proprio come l'operatore muovesse avanti o indietro l'asse Z dello scanner. Quindi qualora andassimo out of range, chiaramente lo scanner non leggerà le informazioni e quello che ci restituirà è un frammento di colore nero. Quindi in questo caso, qualora il problema fosse questo, questo noi cambieremo la distanza dell'asse 0. Oppure è anche possibile che il laser non sia visibile, ovvero in questo caso lo scanner Lucida è stato pensato e progettato per poter acquisire ogni tipo di superficie, il che vuol dire che anche le superfici più oscure e riflettenti, che normalmente diciamo per scanner equivalenti è difficile diciamo riuscire a registrare informazioni, lo scanner Lucida è stato adattato affinché possa registrare ogni tipo di informazione, però è possibile che sia necessario cambiare l'intensità del laser, quindi c'è una schermata che è quella che avete visto inizialmente sempre nel video, dove si vedono tutti i parametri che è possibile cambiare inerenti al setting dello scanner e anche del laser, che può essere variato da 0 diciamo a 10. Chiaramente l'intensità 10 del laser vi permetterà di acquisire superfici molto scure e quindi qualora per esempio ci trovassimo in corrispondenza di una superficie di questa colorazione e avessimo settato eventualmente la macchina su un laser debole, è chiaro che la risposta sarà proprio quella che abbiamo visto nell'immagine prima, ovvero un frammento nero. Quindi che cosa faremo in questo caso? Cambieremo l'intensità del laser, quindi la incrementeremo fino ad arrivare a ottenere la registrazione anche di quel frammento che non è stato visibile. Quindi questa è la seconda ragione per cui potrebbe essere possibile non riuscire a registrare un frammento o più frammenti di uno stesso, di una stessa porzione di opere dipinto in questo caso. Oppure, terza motivazione per cui è possibile che lo scanner non riesca ad registrare correttamente tutta la superficie sono le vibrazioni. Vale a dire, molto spesso, quindi quasi sempre, quando si cerca di individuare un'abitazione, cioè una stanza corretta per effettuare le scansioni, si cerca di isolare l'area di scansione, perché le vibrazioni possono interferire con la registrazione della macchina e quindi vedersi all'interno di una scansione in differenti modi. Magari non si vedrà una superficie nera come avete visto prima, ma quello che si vedrà comunque sarà un'immagine non corretta. Di conseguenza anche in questo caso provvederemo a ripetere la scansione, non cambiando in questo caso i parametri della macchina e cercando di isolare l'abitazione dalle vibrazioni. Vibrazioni chiaramente possono essere una porta che inavvertitamente può sbattere, piuttosto che un operatore che diciamo per svariate ragioni si è trovato a muoversi in area di registrazione e quindi quello che si farà sarà semplicemente ripetere con gli stessi parametri la scansione e poi any other, vale a dire ogni altra possibile diciamo interferenza di scansione potrà poi essere risolta. Quindi al termine di questa operazione di merging quello che inizieremo è l'editing, ovvero la pulitura dei dati originali attraverso un'applicazione che è stata specificatamente pensata per lo scanner Lucida. Quindi questa applicazione ha in sé una serie di tools che vedete qui elencati, i principali perlomeno, ovvero fill alls, quindi diciamo riempire alcune lacune dovute eventualmente a svariate ragioni, anche quelle che abbiamo visto sopra elencate, chiaramente di dimensioni più piccole rispetto a quella che abbiamo visto, perché altrimenti in tal caso si ripeterà la scansione e si effettuerà il merging, oppure ridurre appunto eventuali rumori, pulire soprattutto gli angoli, perché diciamo, la luce in generale genera questo tipo di diciamo, elementi, artefatti che vanno puliti sempre attraverso l'applicazione, oppure anche spikes, quindi la rimozione insomma, di eventuali sempre elementi che sono dovuti all'ambiente, alla luce dell'ambiente. Qui infatti ne vediamo qualcuno. Vedete in questo caso, questa è la schermata proprio dell'applicazione di editing, cioè in basso a sinistra vedete lo specchietto con i tools che abbiamo elencato prima in maniera sommaria, in alto appunto nel primo riquadro piccolo vedete proprio l'immagine aperta e un riquadro che vi mostra nella schermata di destra in dettaglio la superficie che state andando ad analizzare, e in questa immagine vedete una pulizia, diciamo la pulizia effettivamente degli spikes e di quello che è diciamo il principale rumore diciamo dato dall'atmosfera, dalla luce, ecco, che è possibile appunto pulire facilmente in fase di editing. Quindi una volta sostanzialmente terminata questa fase di pulitura, quello che si farà è passare alla fase di stitching. In questo caso, che cos'è lo stitching? Vuol dire proprio l'allineamento delle varie tile prodotte, perché come abbiamo detto lo scanner lavora in moduli di 48 x 48 cm, il che vuol dire che noi, a meno che la superficie che stiamo scansionando non abbia una dimensione che rientri in un'unica tile, può accadere chiaramente con dipinti di piccole dimensioni, quindi di 48 x 48 massimo, in quel caso non dovremo effettuare questa operazione di stitching perché ovviamente basterà effettuare soltanto l'editing, ma qualora appunto avessimo 2/3 o anche insomma più tile, quello che dovremmo fare è effettuare un aligning. Ecco qua, avete proprio un esempio, vedete questa 1A, 1B, 2A, 2B sono 4 tile, diciamo, la croce interna che vedete corrisponde diciamo alla sovrapposizione che è necessario effettuare tra una scansione e l'altra, perché chiaramente potrete ben immaginare che se non dovessi avere una fascia di sovrapposizione tra una tile e l'altra, nel momento in cui io vado ad allineare e a cucire queste immagini si vedrebbe una linea nera, comunque il frammento di connessione. Invece in questo caso quello che andremo a fare attraverso applicazioni come possono essere Photoshop piuttosto che PTGui, con questi tipi di software noi allineeremo, cuciremo le immagini inserendo, diciamo, quasi automaticamente questi software generano punti di controllo automatici che sono punti di corrispondenza tra una tile e l'altra, quindi è possibile che in scansioni insomma molto complesse voi dobbiate intervenire inserendo manualmente punti di controllo laddove la superficie diciamo è molto piana e quindi lo software non riesce a riconoscere particolari punti di riferimento, però tendenzialmente è un processo semi-automatico. Quindi in questo caso quello che si farà, scusate, quello che avete visto prima è effettivamente l'aligning delle tile, diciamo, in formato diciamo TIFF, quindi quello che Carlos vi diceva prima, l'output della macchina, ovvero l'immagine, di modo che noi possiamo riconoscere eventuali errori e visionarli e correggerli in fase di aligning, e successivamente quello che faremo, esatto, è sostituire i file, diciamo, TIFF con i file 32 bit depth che vi ha spiegato prima. Ecco qua, in questo caso chiaramente vedrete un aligning completo come questo, e in questo caso avete idea insomma di una superficie, di quelli che possono essere anche eventuali problematiche. Vedete qui in sovrapposizione, cioè vedete le sovrapposizioni più chiare per farvi capire quello che è il processo di allineamento e quelle che sono le aree diciamo in comune tra una tile e l'altra.
I can, just 1 second, Guendalina. This is an image of one of the projects that I was showing yesterday. This is a big area of wall in the tomb of Seti I, and it is very clear to show you what is the composition of the different scanning tiles that is necessary to record the full wall. So we are talking about something that you can more or less see. It's 1, 2, 3, it's about 4 meters wide by another 5 meters high, more or less, approximately almost 20 square meters of data that we are capturing in sections of 48 by 48 centimeters with this overlap that Guendalina was talking about, this approximately 10% of area that we want to have in common between two tiles that are next to each other, because this way we will be able to stitch together all the different sections, and we will be capable of composing one continuous surface of data. I will just mention very quickly that this is a very extreme case. Normally, we don't have to record such big objects. This is like that because in this particular project, we are recording the entire wall of an Egyptian tomb. We are talking about hundreds of square meters, and we are using different scanners at the same time. We are putting Lucida scanners on top of scaffolding towers. So at the end, it's this composition of different logistics that are necessary to record with the highest possible resolution a large area like this one. And this is why we created the Lucida scanner to have a maximum depth of 500 millimeters or half a meter, because as we are recording the beginning of this wall and we get to the other end of this wall, maybe the variation of depth has been very high. It has been more than 2.5 centimeters. It has been necessary to be readjusting the distance to the wall constantly. So at the end, when we are stitching together all the tiles, we can have something that is below or inside this range of 500 millimeters.
Great. So, diciamo al termine della fase quindi di stitching, dove appunto le immagini sono state ricucite e allineate, c'è l'ultima fase del processo di elaborazione delle immagini, è la fase di blending, vale a dire laddove diciamo ci sono stati dei cambiamenti dell'asse Z, perché come abbiamo visto la superficie ha un rilievo che non riesce diciamo, a rientrare in un unico parametro e quindi lo scanner si è dovuto diciamo, cambiare l'asse Z durante la fase di scansione, quello che bisogna fare è sostanzialmente correggere questo elemento, vale a dire noi avremo nella fattispecie due immagini che in realtà corrispondono a due Z differenti e quindi attraverso diciamo, il processo di blending quello che andremo a fare è correggere questo gap, questa distanza tra le due in modo che la superficie sia completamente uniformata. Quindi andremo a correggere questo elemento così che, esatto, il file 3D finale possa corrispondere ad una superficie continua ed uniforme anche per quanto riguarda l'asse Z. Al termine chiaramente del processo di elaborazione delle informazioni 3D, come diceva Carlos, da un lato diciamo, c'è la registrazione della superficie tridimensionale di un oggetto, ma parallelamente viene portata avanti non attraverso appunto lo scanner che non rileva il colore di un oggetto, fotografia panoramica e quindi al termine quello che noi faremo è di registrare diciamo, le informazioni tridimensionali con le informazioni colore, correggendo insomma quelle possibili distorsioni insite diciamo, al processo di acquisizione fotografico e poi che invece è possibile correggere chiaramente avendo le informazioni tridimensionali che hanno all'interno i parametri appunto x, y e z sulle quali si adatteranno le informazioni colore. Quindi,
so this image is 1 square meter of relief information from this wall painting by Montorfano in Milan. This has been made, as you could see, by 4 different scanning tiles, and this is the result of the process. This is something that is continuous in X, Y, and Z directions. It's like even if we captured scanning tiles independently, it has been possible to make something that is perfectly coherent and continuous in the full area. And this is clearly one of the great advantages of the Lucida system, which is that we are using 3D information as if it was an image. So we don't have to be using other modes of 3D information like point clouds, or we don't have to process our polygon mesh. this is something that would be much larger files, much more complicated to use, whereas the way we are approaching our information is to manage the relief data as if it was a panoramic image. So this is why it is possible to compose entire wall of 3D data with 100 micron resolution with a lot of points of information without having the necessity of using very complicated 3D software or very powerful computers. Having 3D information as a grayscale depth map and then also as a shaded render is what makes Lucida something really useful for conservation purposes and not just for small demonstrations of recording, but something that you could really take into the field, move on site to recording big paintings, big areas of wall, or any other large element that you want to capture. At the end, as Guendalina was saying, it's about registering the color information that was recorded with panoramic photography onto the relief data, so that every detail in the color corresponds to the detail in the surface. So this is just an introduction, so you more or less get an idea of how we work with this information, how we manage the digital data. And what I want to show you now is what are the possible applications of this technology, not for recording paintings, as I was talking yesterday, but mainly about the aspect of research and analysis. Part of the work that we do in the foundation is about applying digital technology for three objectives, three goals, which is the conservation of the originals, the dissemination of the originals, which is mainly what you do when you are making a facsimile, that you can actually place it more available to the public. And then the third goal is usually study or research or getting to learn about that object from the surface. This is why surface learning is the topic of the next projects I want to show you. The act of preserving and studying an object and also disseminating its importance, at the end, everything is related. Because if you are learning more about an object, if you are researching into its history, into its materiality, you are in a way helping the preservation in the long term. Also because if you are helping its dissemination, if you are getting other people, if you are facilitating other people to know this object, you are also contributing to its protection in the long term. On the screen right now, there is an image of the Mappa Mundi of the Hereford Cathedral in England. This is a map that explains very well this idea of using 3D scanning for research. Because this map, which was made around the year 1300, it's something that has been studied a lot. It has been analyzed by cartographers, by historians, intensively throughout the time. But it was never recorded in 3 dimensions. The surface of the map, which is made in vellum, is something that with time, over the centuries, it has been distorting, it has been transforming, just because the pass of time is affecting the skin of the material in a very unpredictable way. So what was originally a flat object, it has become something that has its own topography, its own mountains and valleys. And this is something that it was never recorded that way. The map represents the world, but from a very particular point of view. It represents the world from a religious point of view. So it's not about a geographical accuracy. It's about more a symbolic and let's say, yeah, religious goal, so that all the different elements, places, cities, continents that are represented in the map, they are in a way following the Bible understanding of places and their meaning. So that, for instance, this map is represented having Jerusalem at the center of the map. And this is something that will be important because the center of the map, which is the circular map with having, that is actually oriented to the east, so that Asia occupies the top half of the circle and Europe and Africa occupying the lower half of the circle. It's having Jerusalem at the center. And thanks to the 3D information, it was possible to see very clearly that there is a mark, like a pouncing mark, that has its own relief, its own depth, as if that was the point that was used for actually drawing the circle and drawing the basic structure of the map. This element, that is something that you can see when you are looking at the original map, is much more easy to understand when you are looking at the 3D information that was recorded with the Lucida. Sorry. This is the type of shaded render that we obtained out of the full map. This was done, now that you are familiar with the term, in a series of scanning tiles, also changing the distance from the map. And this is the correspondent grayscale depth map. As you can see, it is more difficult to understand the specific details on the skin because this is the shaded render and this is an image. But this is also an image file that actually contains relief information, because this is a series of tones of gray that are informing us about the levels of depth. This is the type of file that we can use to prototype this digital information into a physical object. So, for example, taking this file, it is possible to send the information to our milling machine. This is a CNC routing machine, so that we are effectively removing the material that we don't want until we achieve the texture in our 3D model. This is, in a way, the opposite to 3D printing, because we are not adding layers of material, but we are removing the extra material from this block of resin. This is a material that is high density but relatively soft for this type of machining. So it was possible to reproduce in a physical element exactly the same information that we have in the digital file. We are talking about not just the general undulations of the shape of the map, but as you can see, also the tiny differences in height because of the ink of the text and the different drawings on the map as was captured by the scanner. This project, it was made mainly for research. So this was made after conversations with the Hereford Mapamundi Trust and the Hereford Cathedral, in order to be able to obtain a proper archive of the conservation state of the map at that precise moment in history, in 2013. But we also wanted to make a physical version so we could demonstrate the quality of the data. So in parallel to working with the digital data, we were also making this reproduction in resin, and then we were taking a silicone mold, and then we were casting that in plaster, in this white plaster, so we could obtain a version of the map that was only shape and relief, and that was without the color, only a plaster reproduction of the surface that we recorded with the scanner. This is similar to one of the objects that I was showing yesterday, this plaster reproduction of the panel painting by Rubens in Madrid. In this case, we are talking about a much bigger object with more radical shape because of the distortions of the material. And we could convert this data into an object that is something you can touch, something that is tactile. So we created this plinth, so we could place this plaster reproduction of the map in a way that it could be understood as a tactile object. It's like a new experience for people visiting the Hereford Cathedral and looking at the original map that, as you can imagine, is preserved behind a glass, perfectly controlled in temperature and humidity. But next to it, we could place this plaster reproduction, this tactile version, so people could not only see the original, but they could actually touch its texture. It was very interesting because this is a true interactive installation. This is something that the Factum Foundation donated to the cathedral, sorry, to the Hereford Cathedral. And over time, since we installed this object on site, people visiting the place, they have been interacting with the object. They have been placing their hands and their fingers on top of this white and clean plaster reproduction. So over time, it has become something that is dirty, something that has all the patina, if you want, of time, but precisely because the people looking for their places, maybe they are putting their fingers on London or Paris or the place where they are coming from, they converted this into something that has acquired its own history. So the project continued, and the intention was to create a perfect facsimile of the map. Because when we discovered the quality of the information that we could capture, it was obvious that it's going to be possible to actually create a true facsimile of the object, because the white reproduction, it cannot be never considered a facsimile. It's like an interpretation of the object, but it's not something that tries to replicate exactly every aspect of its color, character, etc. So in order to make this as a facsimile, we created another version of the plaster, and then we printed the color onto a very thin, very elastic and flexible skin, so that we could print the color on this skin, and then manually we could register it on top of the plaster relief. So it's like a physical way of working with 3D and 2D information at the same time. So for capturing the recording, we were using two different systems, the Lucida scanner for the shape and the relief, and panoramic color photography for the color. And then once we have been working with them digitally separately, we tried to bring them back together as a unity, so that color and relief could be put together again. After placing that skin perfectly registered on the plaster, we are applying vacuum machine to actually cure the glue in between the skin and the relief, so that it could become something solid and perfectly fixed forever. This is the result of the facsimile. So it contains shape, texture, color information, and then some elements were actually finished, gilded by hand. But the research part of this project, and this is what I really want to focus today, is what is the information that we can obtain that was never discovered before. And it is thanks to the 3D recording that we could contribute to the analysis and knowledge of a particular original object. The Hereford Mapamundi is shown in the cathedral along with the board, this wooden, I think it's, if I'm right, this cherry wood backboard. And it's important to look at all the surface qualities in this backboard are in a way like a mirror of the things that were being recorded in the map. This is why I was showing you this specific detail in the center of the backboard, because it is precisely in the same place where that same pouncing mark representing Jerusalem in the center of the map was also visible with the 3D scanner. So after recording the board, also with the scanner, as you can see, it was not possible to really get to the edges. This is the actual shape of the board, which was captured with photogrammetry. Only the central part, it was possible to be recorded with the Lucida scanner because it was flat enough for the scanner to be able to record it. Whereas the actual frame and the decorations and at the top, it's something that has too much volume for the Lucida to be able to capture. So what we did is using photogrammetry as a way to record the full object. And as you can see in the center, there is a weird texture that is noise, that is not enough information to have proper quality. But it was fine because what we wanted to do is combine the photogrammetry data with the central section of the panel recorded with the Lucida data. So that every scratch on the wood, every mark that over time has been present in the object, it is possible to be captured thanks to the Lucida scanner. And what is really interesting is that for the first time, it was possible to do a direct and objective comparison between the relief of the map and the relief of the backboard. This is the same detail, more or less the same area corresponding to the map on the left and to the board on the right. There is a difference of a few years, maybe a couple of years between we recorded the map and we went back to recording the board. But the important thing here, after talking to the cartographers and researchers, is that if it was possible to establish proof or to demonstrate that the map was actually traced and created on top of the panel, it is not something that was added at a later stage, but it was something that was being part of the same object from the beginning, it would be possible to maybe date the map in a more accurate way. We know that the creation of the map was done around the year 1300, but maybe it could be demonstrated that it was actually done maybe a few years later, or maybe in a different place to what history is nowadays believing. I am marking here the different elements, for example, pouncing mark, but also some elements in the map that have been broken, that have been ripped away, because after being glued onto the map, once they have been separated as different elements, there is the mark still visible in both objects. So the broken areas in the map and the remains of glue or any other fixing element at the board. Obviously, we continue taking this information and we rematerialized the backing board in order to have the facsimile of both elements, the map and the board, where people think it was used to actually draft the map on top. following the research on maps, especially when we talk about the relief of maps, is something that in Factum Foundation we have been interested for many years. This is the Gulf map of England, or the Gulf map of Great Britain, if you want. You can see there is a 90 degrees turn. This is actually a map representing Great Britain. And in this case, the surface is very different than with the Hereford map. This recording was made also for research. It was not made to make any physical reproduction, but it was very interesting to see, especially when we compare the image of only color with the image of the color with the relief in the center, how much more information we can read of the way the map has been aging over time. It is possible to see also the restoration that it had. So all the different patches and repairs that have been going on this particular object, they are clearly visible and measurable thanks to the 3D scanning. So this map, it's representing hundreds of places, locations like medieval towns, but also modern places that we can recognize today, like Oxford, like London, etc. And all these places that have been studied a lot by experts, it was interesting to see that in the 3D scanning, what we were finding was a series of pouncing marks, like punchings, like it was not holes, it was more like little ventings on the surface that were happening around the different places, around the villages and the towns and the different cathedrals that were represented in the map. As you can see, on the left, there is the combination of color and relief, and on the right of the screen, there is a shaded render, a detail of the shaded render, in which we have exaggerated the contrast to make the relief even more evident, even more visible. This is another advantage of working with 3D information as if it is an image, because then you can play with contrast and you can make it darker or shinier depending on what you want to see and what you want to communicate. So that thanks to the possibility of looking at the map without the color, and this is very important because the color most of the times is distracting from looking at the object itself. When we look at the relief without the color, it is possible to work on the digital file, making marks of all the different pouncings that are present in the surface of the map. It's like adding layers of information. So thanks to the 3D scanning, it is possible then to go one step forward into creating different files containing new information about the places and especially about the way that the pouncing marks are distributed along the map. Because what the pouncing marks are telling us, it's probably that this is a map that is a copy from another map, because pouncing through the surface is a way to transfer information from one support to the other. If there were holes, if the actual surface of the vellum was passing from one side to the other, maybe that would have been the original map used to make other copies. But because we are talking not about holes, but about just tiny areas with more depth, we could maybe suggest that this is coming as a copy from another map. At the end, this is not for us to offer conclusions about this type of issues. This is for historians and experts to decide what information is interesting or not. The goal here is that we need to provide the data. We need to give the information for others to interpret it. And this is one of the ways, this is one of the reasons why we are doing this job, in order to provide to others new layers of information so that they could take their own conclusions. Also in Oxford, we had the opportunity of working with a very special and very unique set of small drawings by Raphael. This is what you see on your screen. This is more or less the real size of this small drawing. And as I was saying before, when you look only at the layer of the color, you don't really get to understand the complexity of the conservation state of the original. It is when you look at the combination of color and relief, when you start to understand what has happened to this object and what is the fragile state and the maybe unstable condition in which it is preserved in this particular case. You can see here, now that we have removed the color, that it's not only that the paper is being damaged in certain areas, but we also start to see a series of pouncing marks that are actually following the contour of the figures that are represented. And the more I can contrast the image, because at the end it's a shaded image that I can manipulate in Photoshop, for example. So the more I can actually follow that this is a hand and then this is another line of the contour. This is indication that this drawing was maybe also used to create other copies of it. It was used maybe to be the copy of another original. In any case, the pouncing, what is telling us is that this was used as a part of a process of transmitting information from one medium to another. And this brings us to the great cartoons by Raphael in the Victoria and Albert Museum. I was introducing this project yesterday very briefly, but I want to specify today what is the type of information that can be extracted out of this monumental recording that the Factum Foundation was doing a couple of years ago. There was a big team working in the Raphael Court at the Victoria and Albert Museum in London. Guendalina was there, I was there with other members of Factum, and it was a project that took a very intensive 6 weeks, between 5 and 6 weeks, and the goal was to record in color, in relief, and in infrared the surface of the 7 cartoons by Raphael, which is probably one of the most important works of the Renaissance that you can find in the United Kingdom. It belongs to the Royal Collection. It is preserved by the Victoria and Albert Museum, and this research that was carried out in coordination with the staff in the museum was done at the same time as they were doing a conservation treatment and analysis of the actual objects, because normally the way these objects are seen is behind a heavy and thick glass for protection. So during this series of weeks, we had to coordinate with them in order to record the whole area of the cartoon with different Lucida scanning systems, as you can see, working at the same time, working on top of scaffolds in order to get to the specific height in a very limited amount of time, because the cartoons cannot be without the glass protection for long. So this is why it was necessary. Maybe Guendalina would like to explain, but basically this required to work in shifts of morning and then afternoon and then even by night. We should be recording them almost 24 hours over this summer so that we could achieve the goal of obtaining all the information in a very limited amount of time. So the goal of doing a project like this is part of what we are trying to share with institutions and museums about. There is so much that you can learn about the surface of your objects if you are focused on capturing the relief. The very interesting texture of these objects is not something that you could really appreciate if you are a visitor in the museum, because of the glass that I was mentioning, because of the light, because of the distance, because at the end, we are talking about something that is of monumental scale. You are always far from the object and you cannot really look closer to the surface. But we have the privilege of looking at the texture of the cartoons this close and at this distance, and using maybe raking light to play with it. So we could appreciate that all the wrinkles, all the distortions, all the different elements, scars, marks on the surface are nothing but the result of history on the surface of the object. This is a series of papers put together and glued onto a canvas support. So when this was done, probably in 16th century or not far away from when they were created, around 1516, all the different imperfections that happen by gluing very fragile papers onto the canvas are visible today. And this is thanks to understanding this relief from a three-dimensional point of view. This is the end, this is the edge of one of the cartoons. This is where the papers are leaving the canvas exposed. And thanks to the recording, it was possible to have not only the color information in high resolution, but the combination of color and relief for the first time. The goal of this project, as I was saying from the beginning, was to create an archive of multi-layer information that could be placed in the Victoria and Albert's archives, even in their website, so it could be accessible to any person. If you want to go to the Victoria and Albert Museum webpage, you can find a kind of viewer. It's like a browser where you can navigate in the surface of the cartoons exactly the same way as I am showing you now, playing with the layers of information so that you could see the color as a flat image. Then you can also see the combination of color and relief, and of course you can see the relief on its own. But then, because the year 2020 was the anniversary of the death of Raphael, we were also asked to create a facsimile of one of the cartoons, the one that is called The Sacrifice at Lystra. This series of cartoons are representing the lives of Saint Peter and Saint Paul. The cartoons are actually like sketches. This is what was created by Raphael in order to serve as a preliminary stage for the creation of tapestries. The interesting thing that has emerged in this work is that it is not exactly to say that these specific cartoons were used for creating famous tapestries, for example, the ones in the Vatican, or the ones that we can see in Mantua or in the Royal Palace in Madrid. There is a famous series of tapestries that are a series of copies in different locations. But these cartoons are probably something that was done in order to serve as a first step to the creation of the actual cartoons with less detail, with less color information, that are the ones that don't exist anymore, but are the ones that are probably used for the actual weaving of the tapestries. So what the technicians making, what the weavers were actually using as a guide for making the tapestry in the loom, it's a series of cartoons that they could use to follow the contours of the figures so they could understand what is the composition, what is the drawing. But then they were using this type of cartoons with all the complexity of color, probably as a reference, something you could have maybe hang on the wall so you could understand what is the color that you have to reproduce with wool and silk. So as I was saying, for last year's celebration of Raphael's anniversary, we created the facsimile of one of the cartoons in order to be shown in the Scuderia del Quirinale in Rome, along with many other original pieces by Raphael. So in this show, we had the possibility of including this one-to-one scale, so real size reproduction of the cartoon. And even people visiting the exhibition, they were not sure if they were looking at an original or if it was a reproduction. So it's not until you actually look at the label where you get to understand that this is a reproduction made in the 21st century, made using digital technology. Before you realize that this is a facsimile, you might be for a second shocked by the fact that you have been looking at this without any glass and maybe it was the original traveling from London. The processing of the data of the Raphael cartoons was actually done in archive, and Guendalina was in charge of managing the team that was processing all the hundreds of scanning tiles, editing them together, stitching them together, making sure that all the steps that I was showing you before, that we were sharing with you, they were actually applied to each centimeter of each of the cartoons at from the Victorian Albert. This research going on with the cartoons, it has a very interesting version when we are working with tapestries. This is one of the tapestries that is in the Palazzo Ducale in Mantua, and it's representing the same topic of the sacrifice at Lystra. And as you can see, the tapestry on the wall, it's in a way mirrored with respect to the cartoon. We go back. This is the cartoon that was used for making the tapestry. And the way this works is that you are actually representing something that is mirrored. It's like a symmetric view from what you are actually then making as a tapestry. We were doing this work also in collaboration with the Palazzo Ducale in Mantua as a way to demonstrate different technologies. So not only the Lucida 3D scanner was used for recording a section of this tapestry, but also the full area was captured with photogrammetry. And this is one technique that I will be focusing on in the next session of the course. But the small section that we could record with the Lucida, it was showing the texture of the tapestry with this level of detail. It is possible to actually see every single thread of the tapestry, to actually count threads, and to see what are the distortions of the different parts of the weaving and what is the resulting relief of the fabric. This section, it's showing this particular detail. This is a very lower part of the tapestry. And I wanted to show you this comparison with the same area, but of the cartoon in London. It is believed that, in a way, it is very similar, the representation of the figures and the compositions between the cartoons in London and between the tapestries in Mantua. This is a research that is in process, but this is an ongoing work that I wanted to highlight as something that you can only do when you are actually using 3D information. This is not just about comparing color. This is about actually understanding these objects, paper and fabric and the wool texture, as three-dimensional objects. And this is the only way we can actually measure and compare the distortions and the different ways that these things have been evolving over time. Guendalina was recording this tapestry in Mantua. Maybe I am forgetting something important to mention, if you want to.
Just that the museum basically has completed an important restoration work on the tapestry that began basically in May 2020, I think, yes, which will basically improve the state of conservation of the works. And then I think it would be very interesting to finally record the 9 tapestry belonging to Palazzo Ducale, just to compare the 9 tapestry with the tapestry of the Victoria V&A, as you said, and do exactly what you are doing now. So let's compare this detail and trying to understand the history of this tapestry.
Absolutely. So that is a work in progress, and we will be able to give you more information hopefully very soon. But going back to the paper, going back to the actual cartoons, I want to keep focusing on the very small detail of these objects. You can see also here the pouncing marks. You can see that what I was mentioning earlier, that maybe this series of very powerful colored cartoons were not used specifically for making the tapestries, but maybe they were originating further copies, maybe one more copy or maybe others, through the use of these pouncing marks in order to transmit the figures and the information from one object to the next. But the real discovery in this work, and this is also something that still needs to be discussed and studied, is the appearance of a watermark. So this circle that you can see on this texture is something that only when you record in 3D, or if you are using a very strong raking light, is visible. When we were working in London, this thing emerged, and rapidly there was a very strong feeling of excitement about this more or less discovery, because it was a very good indicator of the possible provenance of the paper that Raphael was using for making these cartoons. As you could see, each of these cartoons, which is measuring, I don't know, between 5 meters wide by 3.5 meters high, is composed by hundreds of small papers, maybe DIN A3 size, something like that. So each of these papers, in theory, they should have their own watermark, explaining it's like a brand. It's like what is marking the provenance or the origin of that particular paper. By playing with the contrast in our shaded renders, we could highlight more or less this element in order to be able to share this with the conservators at the Victoria and Albert Museum, who are the ones who really need to offer any conclusions on this. But also in London, when we were recording another cartoon, but in this case by Michelangelo, the cartoon of Epifania, the appearance of watermarks of each paper, it was very obvious. It was much more obvious than in the case of the Raphael. I'm showing you different visualizations of the data, and these are images of the actual recording of that cartoon, which was done, as you can see, placing the scanner facing back and facing down in a horizontal setup, so that the cartoon could stay horizontal on a platform and it doesn't suffer by being vertical on a wall. This is also a possibility that we could do. And we also used the same structure for capturing the color. In this case, for recording the color, we were not using panoramic photography. So we were not shooting pictures from one point, but we were doing parallel recording. We were actually taking pictures from the same distance and then moving the camera in different rows and columns until we compose the full mosaic of the image. You can see that it's the image is rotated to the right because the original orientation is like a vertical cartoon, and you can see the three figures drawn by Michelangelo very clearly. And then when I incorporate the layer of the relief, you can start to see the different papers that compose the object. This is a very interesting layer of information. This is the conservation report that was done by one of the experts at the British Museum, and it contains all the different comments and highlights and different classifications of the cracks and other elements that you could find on the cartoon. This was done before we actually made the recording, and the museum provided us with this layer of information that then we incorporated to our recordings, making a perfect registration of the marks of the restorer into the marks of our recordings. What is interesting here, as I was saying, is that the watermarks were really visible. This characteristic anchor shape is typical of a particular time and a particular location, and it's visible in other works of art as well from the time, maybe from Florence, maybe from a particular region in Italy. This is a diagram marking the different sections of paper. So each of these sections of paper was showing one of these anchor watermarks, which in a way they were very similar, or we think it could be similar to the ones that we found in the Victoria and Albert Museum with the Raphael cartoons. I will go very quickly now because I want to show you other examples about how we have been trying to apply the 3D scanner for recording paper. This was a demonstration with the British Library in London. And this is actually maybe in a way too flat for the scanner. So elements like this are very easy to capture. So when there is a strong relief aspect, it is not difficult to record. And when there is a very strong texture, like in this case, also like watermarks in the paper, it is possible to be captured. Basically, so you understand, what you can see with your eyes and with a proper Raking light, it's normally what you can capture with the Lucida scanner. But you cannot go, let's say, to a microscopic level. This is another type of survey, another type of recording that we will also explain in one of the next sessions, like what happens when you want to see farther and you want to go and see even a smaller detail to what you can see with your naked eye. So that this is an example of when there are limitations for the scanner, when you are trying to detect things that are just too flat for the Lucida to see, to record. So going back now to Madrid and looking at the pages of books, this is one of the most important manuscripts in Spanish language. This is the Glosas Emilianenses, and it is like a book containing texts in Latin for religious services, for the Mass. But then what is interesting about this manuscript is that it contains what they are called glossas. Glossas is like the different handwritten annotations that are accompanying the actual texts on the margins, on the edges of the pages that they are believed to be one of the earliest representations, one of the earliest versions of the Castilian language, the Spanish language. So the glossas is what we were really trying to capture with the Lucida scanner. Each page was recorded with color in order to have a high resolution color recording, but then we placed the Lucida scanner in this way on a desktop configuration in order to be able to record also the surface of a specific selection of pages, trying to, well, this is the actual cover made in wood. This is the edge of the book. But what we were trying to see in the pages is the part of glossas that maybe they have been with some incision of the paper. So even in those cases that they have lost the ink, and this is one of the examples I was mentioning yesterday to one of the questions, in the cases that, for example, they have lost the ink and they are no longer readable, maybe we were trying to see if through the 3D scanning it was possible to see the incisions on the paper. This is actually a limitation of the scanner. We so far haven't been able to get proper information of this type of relief. But I will show examples in which using other systems, other equipment, like for example, stereophotometric recording that I will be discussing in one of the next sessions, it was in fact possible to determine the presence of text that has lost the original ink. Then to finish, and staying with books and staying with the recording paper, this is a very good example of what happens when you are trying to explore the full potential of this type of recording. This is one of the most important versions of the essays by Montaigne. This is preserved in the library in Bordeaux. And it's a copy which contains annotations by Montaigne himself. And this is why it is important. We recorded it with color and relief in order to have a proper archive of a selection of pages so that it would be possible to have like a 3D representation of the actual handwriting of Montaigne. These are examples of the pages that we were recording. You could see that the relief of the main text, the main printed text, is visible, and it's only starting to be visible the handwritten text around the main body of text. This recording, it had a very interesting outcome when it was selected by the American artist Jenny Holzer to be converted into something at an architectural scale. So thanks to the recording that we did of specific pages of this important book, she decided to collaborate with us in order to create something that was enlargement of this information, of this text, obviously after a very complex digital manipulation to increase the size 50 times from the original size, and also to play with the thickness, making the relief of the text as inverted or as negative text, so that she could complete as a work of art a series of facades of the building, which is by Jean Nouvel, by the architect Jean Nouvel, and is the Museum of the Louvre in Abu Dhabi. This is a good example of what are the translations between information that can happen in between cultural heritage and conservation, and between and with contemporary art. Once you have recorded something in high resolution, it is possible to, if you do it properly, if you do it keeping their complexity and keeping the interest that it has, it is possible to maybe give way to endless interpretations that could make these objects visible to people in different ways. So finally, the way we were working with Jenny Holzer, she's now on the screen, is to recreate for her 3 different types of texts. The manuscript that I was showing you before from Montaigne, a text in Arabic that was recorded in Turkey, in Istanbul, and then this very special text in cuneiform from an Assyrian tablet that was also scanned with the Lucida 3D scanner in Berlin. The tablet is something that measures only a few centimeters. We were focused on scanning it in all the 6 sides of it. It's one of the clay tablets that contains a very important and very inspiring text in cuneiform form. And then, thanks to this scanning, it was possible to enlarge it again another 50 times or so in order to become part of the facade, in order to become part of the architecture. So this translation between text information with archaeological origin into architectural information in a contemporary environment, it's, I believe, something very interesting, and it has to be explored even more by today's artists. Finally, I would like to conclude with showing an example which is also a limitation of the Lucida scanner. This object in the British Museum, it was not recorded with the Lucida scanner. It was captured with 2 complementary systems, something that it's called structured light scanner or white light scanner, and also with close range photogrammetry. These 2 methods that I will be discussing in the next class are indicated for sculptural elements, something that we can consider like a 3D object, not just a surface with relief, but something that is really a volumetric thing. And they are also very high resolution methods. So in addition to recording the shape of this statue, it was also possible to record the text in cuneiform that was written on top of the actual surface of the left shoulder of the statue. This is a comparison between the white light scanner data and the photogrammetry data. You can see there is a bit more noise on the cheek, on the right hand side of the face, but you can also focus on the quality of the cuneiform text that is on the left shoulder, especially when you are comparing photogrammetry and the Breukman. The Breukman is a commercial brand of the white light scanner. So for some cases, or even for some parts of the object, it was better to use information from one system. For actually being able to read the cuneiform text, it was better to go to the data capture with the white light scanner. The importance of this statue is that it represents Idrimi, who is one of the first Syrian refugees in history. He was actually from 13,500 years ago. He was escaping from Aleppo in Syria, and he ended up in being the king of a region in Turkey, in what is now Turkey. So this is why it was so important, this statue, and it was so important the text that was made on its surface, because when we were making the reproduction, it was very important that the text was being visible and it was something that people could read. So we invited experts, and this is what you can see on the image, experts that could tell us if the cuneiform text was properly visible, it was properly readable, because it was essential to have this text properly visible. The text is explaining a biography of this character, of this person. The statue was made by Idrimi himself. he ordered it to be made. He was in order to show his biography on the actual representation of his statue. So the text is telling about the biography of this person, and it's also a curse to anyone destroying the statue. So this is why we were so interested on doing a proper recording and a proper reproduction, so we could be safe from any curse that could happen. We will see in the next class how to record this type of objects, how to use other types of systems for focusing on volumetric originals like this one. So we will be jumping one more dimension. We will not be focusing only on the texture of things, but we will be looking at something that is more architectural and more sculptural from the next session. Thank you very much. And if you have questions, of course, we will be happy to answer.
Thank you very much to both of you. As usual, it has been really interesting. And yes, in the meantime, we wait for some questions. I maybe ask you two small questions. One is especially for Guendalina. The tapestries in Mantova. So you mentioned that Mantova started a big restoration project. So did you record it after the restoration, I guess?
No,
right?
Recorded this tapestry before restoration, but we will probably record it as well after restoration now, because the Palazzo Ducale is interested in completing the recording of the 9 tapestry inside the building. So we hope to do it soon.
Yeah, yeah, I guess then they also will have data on the before and after.
Yes, this is very
the restoration.
Important for us to do the recording before and then after restoration to compare the data.
And another curiosity for the Cenacolo Vinciano. So I think Carlos mentioned that you recorded 1 square meter of the Montorfano fresco. Was it also for restoration reasons, like a particularly damaged part, or was it different test?
The goal of that recording was to, as if it was an anticipation of something we really want to do, which is to apply the Lucida 3D scanner for recording the complex surface of the Last Supper. We wanted to show how it worked and what are the possibilities, of course, on a different wall before having the possibility, hopefully in the future, of applying the same system for the actual Last Supper. So it was mainly as a demonstration, like as a demo that we wanted to show how it worked. But we chose a very specific square meter on the wall because that area was representing, if I'm right, Guendalina, one of the donors of the painting of this crucifixion. And it is believed that it was actually painted by Leonardo.
Exactly.
And this is why it was in a worst preservation state because of his experimental attitude at that time. And it is not as well preserved as the rest of the fresco. Is that correct, Guendalina?
Yes, totally correct.
A double result. It was a trial, maybe to convince of the importance of this type of the recording, and also scientific purpose.
Well, you could see that from a scientific point of view, there is so much you could understand if you were applying this type of high resolution technologies on the surface of the Last Supper. This is a work of art that contains so many layers of information, all the different hands that have been actually trying to work on it, trying to repair, trying to recover the original aspect, all of that, you don't really get the real complexity of it when you visit the original. But maybe combining the possibility of looking at the original with the option of seeing on the screen very fine detail in color, in relief, in combination of both of them, it could increase the experience to make it something really unforgettable, I think.
I found it really interesting also the part on related with the watermark. Of course, I asked you yesterday if Lucida can be the tool for books, rare books as well, and you answered me. I will talk about it another time. So today, and as you mentioned, with the stereophotometric would be, but also dive into watermark studying. Well, yeah, for rare books, the filigrana in Italian is extremely important. So we absolutely look forward to that lesson too.
This is part of the unexpected things that happen. You think you are going to be recording some specific things, but then you find out that maybe the interest is somewhere else. Once you have the data and you can provide the archives to the institution who is responsible for the object, the idea is that the information could be studied over time. So the way we do it is that we want to preserve the data as unprocessed as possible. So exactly as we recorded, without applying any simplification, any optimization of the data. So maybe in the future, other people with better resources, with better technology, could even reprocess this information. They could maybe go to the videos that we captured with the Lucida scanner and maybe process them again with higher resolution or with higher quality. So we are not closing doors for others to improve the data. We want to keep it open. The whole Lucida system is supposed to be open for others to use it and for others to improve it, both in its hardware and its software, and also in making the data something that you can really work with. This is why it's so important to keep the video, the original video files, the very simple recording of a line of light on top of the surface, as pure and virgin as possible, because then this way it will be possible to go back to this data and maybe make it even more useful for the next generation.
With Lucida, the video, the AVI format is the real conservation, the master file.
Yeah.
I don't see any questions. They have been very clear, probably. If there's nothing more to add, I think it's 6:30, so we can say goodbye.
Very well. So thank you very much. Thank you everyone for attending. Thank you, Costanza.
And see you next time. That will be the 19th of October, if I remember well. Yeah. See you soon.
See you very soon. Bye. Thank you.
Bye.